Hey guys, Alan here, back in the workshop. Small project this time. If you watched previous videos, you would have seen me playing around with this ER40 collet chuck in the dividing kit, and the flats on the back of this thing are 46mm wide or apart. So the only spanner I had that would fit that was this giant 18-inch adjustable, which is just ridiculously out of scale for this sort of job. So I'm not putting up with that anymore. And I found a spare open-end spanner. I don't know what it came from, but anyway, I found a spare open-end spanner that can have the jaws opened out to 46mm, and that's today's project. So, I'll get to it. So, this is the spanner that's volunteered its services, and I've marked out here the 46mm. That's roughly what's going to be required. So, let's get it on the milling machine and start removing some metal. Actually, before I put it on the milling machine, I'll just point out the obvious. This has got a taper on both sides, so I want to line it up on the milling machine on the centre line. So I need to find out what the included angle is and then halve it and set the spanner up like that. Okay, let's start off with a look at my clamping strategy. This thing is all over the place. It's all different widths, thicknesses and the like. So I want to try and support it basically in three places. But anyway, start off with an indexing block that's fitted into the rear slot, backing block. So I'll push the spanner up against that, and I'm going to sit it on this bar here, which will support it in two places, and on the tail back here, so it'll be supported in three places basically. Trying to keep my hands out of the way here. So that's given me something to clamp against, and to make sure I get the pressure on both points here, I'm going to use this thing, which is sort of almost a ball type thing, just to put pressure in the middle between the two contact points, and then these clamps to hold it down. So let's do that. I'll bring you back. So that's got this guy clamped firmly to the table and held against a stop, so it's in a position from which we can do some measuring. So now I've got to work out what this angle is. So to do that, I'm going to put a short parallel here, and then use this sine bar because it's got two contact points, which will go like that. And then I'll be able to put a gauge block stack in here to get this running parallel. And I could use the sine bar and the height of the gauge block stack to calculate the angle, but I won't need to. I'll just use the thickness of the gauge block stack, and when I halve it and set it up again, I'll have this thing hopefully set on its centre line. So let's find out what gauge block stack I need here first. Okay, so we'll start with a guess at 7mm for the thickness of the stack. We'll slip that in there, and we'll see what we get. So zero this. Right. Well, it's pretty close, but I reckon we can do a little bit better. So that was 7. We'll take the 7 out and put 6.9 in and see if that makes this a bit better. So there's a 5. You probably can't read those numbers, but there's a 5 and a 1.9. We'll slip that back in there and see what difference that makes. Okay, so I'll just turn the dial gauge around a little bit so maybe you can read it a bit more clearly. Anyway, so that's got 6.9 as the gauge block stack. Let's see how that looks. Well, you'll be pretty happy with that. There's absolutely no point trying to chase that any further, given what we're playing with. So 6.9 it is, so now I've got to set it up with half of that, which would be 3.45 I suppose, and then hopefully the spanner will be on the centre line and we can start doing some machining. So I'll bring you back when I'm set up with that. Now I don't know how well you'll be able to see this, but if we have a look from another angle, we can see, here's my back block, the sine bar and the 3.45 gauge block stack with this jammed up against it. So now hopefully this spanner, the centre line of the spanner, is parallel to the movement of the table, and I'm sure it'll be good enough for what I'm trying to do anyway. It's not a precision thing. I was just trying to make sure that the jaws of the spanner lined up. Okay, let's get ready to start cutting metal out of the jaws. Okay, so now I want to get the cutter centred on the opening. So I've got a choice. So I can either centre on the inside of the existing as cast jaw, or on the outside at the widest, well, at some point. I think I'll do both and see what the difference is. Well, that's the centre based on the jaw opening. Okay, so I've saved that centering to the absolute, and I'll do the outside to the incremental, and I'll be able to compare the two. So now I'm centred on the outsides and comparing it to the previous one. It's a 0.4 millimeters difference. So that's pretty close really, and it's probably allowed for really by the roughness in the casting here. So I'm going to go with the taking off the jaws, the first one I did. So now to getting a cutter sorted out. So I've decided to remove some of the material using an insert cutter. So we'll start there. And I've got to come to get my 46, I've got to, and that's 1.25 inches. So I've got to come nearly 7 millimeters each side. Let's come forward to start with, and that might leave 3. Don't like the sound of that. Don't think it's supported well enough. Okay, I'll give that a try. I haven't never tried doing it like this before, but I put a wedge under each side, and let's see how that difference that makes. Why has the noise changed, I wonder? I just realised I didn't tighten the chuck up, that might be part of it. Oh, reached the maximum treble. That frightened the crap out of me. I've lifted the table up to get a bit more travel, and that noise was this wedge had come loose. Alright, we carry on. 0.0 the quill DRO as well, so make it easier to know when I've got to stop. Well, that's made a good start. Right, I think it's time to switch over to a smaller diameter cutter. So I've switched over to an 8mm cutter, and to get my 46mm I've got to cut about just under 19mm each side of centre. So we'll start off with 18 and see what that looks like. Okay, I think you can be able to see I've made a bit of progress, and this is a 45 stack, which just fits in there. It's actually slightly loose. Anyway, that's a 45 stack, so that's where we're at. Another millimetre to come out, half off each side. And I also have to start thinking about what I want to do in these areas here. Ideally, I'd cut a big radius around here, but the appropriate radius is actually bigger than the opening, or sorry, the appropriate diameter is actually bigger than the opening. But I still could use the boring bar and set it to be the opening and just take whatever it can give me, and it will just be it'll go in a little bit deeper than it needs to. But the other option is just to come down with the small end mill here and then clean it all up with a file afterwards. Well, I'll decide when I get there. I'm not sure yet which way I'm going to go. But for now, I'm going to take the final 0.5mm off each side, come to size, because then I'll be able to see exactly how much I've got to deal with back here. So first up, let's see if we've got the opening the right size. Okay, so I was actually shooting for a finished size of 45.85 because the measured flats is actually 45.8, and I thought, well, I'll just have a little bit of clearance. Anyway, so that's 45.85. She's a little bit snug. There we go. Might still be a bit of a burr or something. Anyway, so I think we'll call that hit the target at 45.85. Yeah, it's certainly a close on 45.85. Come on, I don't cut myself on that too. I've already scratched myself several times. Right. Don't need this much accuracy, of course, anyway. It's only a damn spanner. It's just an interesting challenge always to try and hit particular targets, and it comes in handy for when you will actually need it. So now I've got to focus on cleaning these areas here out somehow. So let me get on with that. Okay, well, I decided to cut this material out the back here by pecking basically around the line that I previously marked, and it's going to be somewhere near it. Most important thing, of course, is that I've got enough jaw length here. I reckon I'll probably just have, I might have to clean that little bit there out. So we're just about done, but this is what I've been doing all around. Okay, well, I reckon that's it. I've got a Oh, it's a little bit steppy, but so what? If I get super enthusiastic, I might clean it up with a file. But I think we're done, and it's time to go and test it, see if it will get the job done. A bit nerve-wracking because it was an awkward shaped thing to mill, and I wanted to hold it to fairly close tolerance. So, oh, I suppose if I've messed it up, it's always a file. Anyway, let's take it out and check it out. Okay, well, I've taken it out, cleaned it up a little bit, taken the burrs off. Turned out alright, I reckon. Of course, whether it looks alright or it doesn't is irrelevant. Does it do the job? So let's go over to the ER40 collet chuck and see if it works. Okay then, moment of truth. Oh, look at that. That's a really nice fit on there. Alright, so will it work? Is this done up or not? It's not done up, right? So put something in there. Oh, that's big enough, as tight as I ever want to make that. Here. Yep. So I'm pretty happy with that. This guy can go back into the cupboard. This guy now lives here as the tool for this job. Okay. And here's a real close-up of the fit. Well, that's another project finished with a useful result coming out of it. Another tool for the kit bag. Probably the most interesting thing about this project was the issue of setting the spanner up, getting the angles right, and then again maybe doing the peck out to get the shape round here was interesting as well. Anyway, everything you do, you learn a bit. Hopefully not from too many mistakes. Anyway, this one turned out alright. As I say, hope you enjoyed it, and see you on the next one.